Welcome to my channel Sajina.K.Jayasankar. Today we will discuss how to solve numericals based on the topic equation of motion. Before solving numericals, let us recall about the three equations of motion. The first equation of motion, v is equal to u plus at. This particular equation gives us the relationship between velocity and time. So the first equation of motion, v is equal to u plus at, where v is the final velocity of the object, u is the initial velocity of the object, a is the acceleration, t is the time taken. Now let us derive this equation. So already we have learned that the definition for acceleration. Acceleration means rate of change of velocity. So we have the equation for acceleration, final velocity minus initial velocity divided by time. That is, acceleration is equal v minus u by t. Or you will get at is equal v minus u. Finally, we will get v is equal to u plus at. Second equation of motion, that is s is equal ut plus half at square, where s is the total distance covered by the object, u is the initial velocity, t is the time taken, a is the acceleration. So this particular equation s is equal ut plus half at square will gives us the relationship between position and time. Now let us see how to derive this equation. So already we have learned this equation for average velocity. Average velocity is equal initial velocity plus final velocity whole divided by 2, or u plus v by 2. So what is velocity? Velocity is equal distance by time. From that equation we will get distance travelled is equal average velocity into time. We just substituting the value or equations for average velocity here. So that we will get s is equal u plus v by 2 into t. Now again, what is v? V is equal u plus at. So we have the equation s is equal u plus v by 2. First u plus, instead of v we are putting u plus at by 2 into t. We are using here v is equal u plus at. By solving this, we will get s is equal ut plus half at square. Third equation of motion, v square is equal u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, s is the total distance covered by the object. Now let us see how to derive this equation. From second equation of motion, we have the relation s is equal ut plus half at square. And from first equation of motion, we have the relation v is equal to u plus at. By rearranging this equation v is equal u plus at, we will get t is equal v minus u by a. Now, putting this value in equation s is equal ut plus half at square and rearranging this equation using with the equation a minus b whole square is equal a square plus b square minus 2ab, we will get v square is equal u square plus 2as. Now let us study how to solve numericals based on the topic equation of motion. Question number 1. A body starts from rest with a uniform acceleration 2 meter per second square. Find the distance covered by the body in 2 seconds. Here, initial velocity u is equal 0 because the object is starting from rest, which means initial velocity is equal 0. And acceleration is given as 2 meter per second square. Time is given as 2 seconds. And we have to find out the distance covered by the object. So we have the equation S is equal ut plus half at square. By substituting the values in this equation, we will get S is equal 0 plus half into 2 into 2 square. Finally, we will get S is equal 4 meter. Question number 2. A body starts with an initial velocity of 10 meter per second and acceleration 5 meter per second square. Find the distance covered by it in 5 seconds. Here, initial velocity u is equal 10 meter per second because the body starts with an initial velocity. So, initial velocity is given as 10 meter per second and acceleration is given as 5 meter per second square. T is equal 5 seconds. Again the equation S is equal ut plus half at square. Substitute the values and we will get S is equal 112.5 meter. Unit is very important. Question number 3. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. After 2 seconds, it is 33.6 km per hour. And after further 2 seconds, it is 37.2 km per hour. Find the acceleration of the vehicle in meter per second square. Is the acceleration uniform? Solution. Acceleration. Equation, we have the equation for acceleration, change in velocity by time taken. So let us find out the acceleration in the first 2 seconds. So acceleration is equal to final velocity minus initial velocity divided by time. So we will get 33.6 minus 30 whole divided by 2. So that 1.8 km per hour square. We have to convert the same into meter per second square. So, to convert kilometer per hour square into meter per second square, we have to multiply 5 by 18. So, by multiplying 1.8 into 5 by 18, we will get 0.5 meter per second square. Now, in the next 2 seconds, again acceleration is equal final velocity minus initial velocity divided by time. So, the final velocity here 37.2 minus 33.6 whole divided by 2 km per hour square. So, we will get the answer 1.8 km per hour square. Again, we are converting the answer into meter per second square by multiplying 5 by 18 so that we will get a 0.5 meter per second square. So, from equation number 1 and 2, we can say that acceleration is uniform. Because in both the sides we have acceleration is equal to 0.5 meter per second square. So that acceleration is uniform acceleration. Question number 4. A body initially at rest starts moving with a constant acceleration 2 meter per second square. Calculate. First question, the velocity acquired. Second question, the distance travelled in 5 seconds. Solution. Initial velocity u is equal 0 meter per second because the object was at rest initially. Acceleration is equal 2 meter per second square and time t is given as 5 seconds. Let v be the final velocity And from the equation of acceleration, we have equation acceleration is equal v minus u by t. So we have v minus u by 5 is equal to and u is equal to 0. By substituting all these values in this equation, we will get final velocity v is equal 10 meter per second. Now second part, let s be the distance travelled. We have the equation v square is equal u square, v square minus u square is equal to as. By substituting the value for v as 10, u as 0, a as 2, we will get the value for s is equal 25 meter. Question number 5. A bullet initially moving with a velocity 20 meter per second strikes a target and comes to rest after penetrating a distance 10 centimeter into the target. Calculate the retardation caused by the target. Solution. Initial velocity u is given as 20 meter per second. Final velocity v is equal 0 because this bullet strikes a target and come to rest. Come to rest means the final velocity becomes 0. And distance travelled is given as 10 centimeter. We have to convert it to SI unit. So 10 centimeter is equal 0.1 meter. To convert centimeter into meter, we have to divide it by 100. Let acceleration be a. Then using the third equation, v square minus u square is equal to as. By substituting all these values, we will get acceleration is equal to minus 2000 meter per second square. Negative acceleration is called retardation. So that we can take retardation is equal to 2000 meter per second square. Question number 6. A train moving with a velocity of 20 meter per second is brought to rest by applying brakes in 5 seconds. Calculate the retardation. Solution. Initial velocity u is given as 20 meter per second. Final velocity v is equal to 0 because the train come to rest. That's why final velocity is equal 0. Total time taken t is equal 5 seconds and acceleration let it be a. Using the first equation of motion v is equal u plus at, by substituting the value for v, u and t, we will get acceleration is equal minus 4 meter per second square. Again, acceleration has a minus negative value, so that it's a retardation. So the retardation is equal 4 meter per second square. Question number 7. A train travels with a speed of 60 km per hour from station A to station B and then come back with a speed 80 km per hour from station B to station A. First question, find the average speed. Second question, find the average velocity of the train. Solution. Let S be the distance between station A and B. We have the equation for average speed, which is equal total distance by total time taken. So what is the total distance here? It is the distance from A to B plus B to A. So we will get total distance is equal S plus S equal to 2S. Now, what is total time taken? Total time taken is the sum of time taken to travel from A to B plus time taken to travel from B to A. Finally, we will get S by 60 plus S by 80. By taking LCM and by cross multiplication, we will get 140 by 4800 S. Second part. Find the average velocity of the train. What is average velocity? It is total displacement by total time taken. Because the train starts and ends at the same station, the displacement is 0. Because the initial point and final point of the train is same. So that total displacement is 0. If total displacement is 0, average velocity is equal 0 by total time taken. So we will get average velocity is equal 0. Question number 8. A train is moving with a velocity of 90 km per hour. When the brakes are applied, retardation produced is 0.5 meter per second square. Find, first question, the velocity after 10 seconds. Second question, find the time taken by the train to come to rest. Solution. Initial velocity u is given as 90 km per hour. We have to convert it into meter per second. So we will get velocity u is equal 25 meter per second. Final velocity v is equal 0 meter per second. Because brakes are applied, which means train come to rest. And acceleration is given as 0.5 meter per second square with a negative symbol, which means the train is retarding. And solution for first question, let v be the velocity after time t is equal 10 seconds. So using with the first equation of motion, v is equal u plus at, and by substituting the values for u, a and t, we will get final velocity v is equal 20 meter per second. Now the second part of the question, find the time taken by the train to come to rest. So let t prime be the time taken by the train to come to rest. Using with the first equation of motion, v is equal u plus at. By substituting the values, we will get t prime is equal 0 minus 25 by 0.5 with a negative symbol. That is t prime is equal 50 seconds. Question number 9. A car travels a distance 100 meter with a constant acceleration and average velocity of 20 meter per second. The final velocity acquired by the car is 25 meter per second. First question, find the initial velocity of the car. And second question, find the acceleration of the car. Solution. Distance travelled S is given as 100 meter. Average velocity v is given as 20 meter per second. And final velocity v is given as 25 meter per second. Let u be the initial velocity. And we have the equation average velocity is equal initial velocity plus final velocity by 2. So by substituting the given values, we will get initial velocity is equal 15 meter per second. Now the second part of the question, find the acceleration of the car. Let small letter a be the acceleration of the car. We have the equation v square minus u square is equal to 2as. So all the term except a is given. V is given, u is given and s is given. By substituting all these values, we will get acceleration is equal to 2 meter per second square. Question number 10. When brakes are applied to a bus, retardation produced is 25 cm per second square and the bus takes 20 seconds to stop. Calculate, first question, calculate the initial velocity of the bus. Second question, calculate the distance travelled by the bus during this time. Solution. Final velocity V is given as 0. Acceleration is equal to minus 25 centimeter per second square. We have to convert 25 centimeter per second square into meter per second square by dividing it with 100. So we will get acceleration is equal to minus 0.25 meter per second square. And time taken t is given as 20 seconds. And the first question solution, let u be the initial velocity. Using with the first equation of motion v is equal to u plus at. By substituting the values given, we will get u is equal 5 meter per second. And solution for the second part of the question, the distance travelled by the bus during this time. Let s be the distance travelled. Using the third equation of motion, v square minus u square is equal to as. Here, all the term except s is given. So, by substituting the values, we will get s is equal 50 meter. Question number 11. A body moves from rest with a uniform acceleration and travels 270 meters in 3 seconds. Find the velocity of the body at 10 seconds after the start. Solution. Initial velocity u is given as 0 meter per second because the object was at rest initially. Total distance travelled by the object s is given as 270 meters. Time taken to travel the distance 3 seconds. And let a be the uniform acceleration. And using with the second equation of motion s is equal ut plus half at square. By substituting all the values except a, we will get s equal 60 meter per second square. Now, let v be the velocity of the body 10 seconds after the start. And we have the equation v is equal u plus at. By substituting all the value for u, a and t, we will get final velocity is equal 600 meter per second. Question number 12. A body moving with a constant acceleration travels the distances 3 meter and 8 meter respectively in first second and second second. Calculate first question the initial velocity and second question calculate the acceleration of the body. Solution. Let the constant acceleration with which the body moves be a. Given the body travel distances, first s1 is equal 3 meter in time t1 is equal 1 second. Same body travel distance s2 is equal 8 meter in time t2 is equal 2 seconds. And we have the equation s is equal ut plus half at square. By substituting the value for s1 and s2, we get s1 is equal ut1 plus half at1 square, put it equation number 1. And s2 is equal ut2 plus half at square, at2 square, put it to equation number 2. By subtracting equation number 2 from equation number 1, we will get s2 minus s1 is equal ut2 minus ut1 plus half at2 square minus at2 square. By taking common factor, we will get s2 minus s1 is equal u into t2 minus t1 plus half a into t2 square minus t1 square. And by substituting the values, we will get acceleration a is equal 10 minus 2u by 3. And substituting the value for a in equation, we get s1 is equal ut1 plus half into 10 minus 2u by 3 t1 square, or 3 is equal u plus 5 minus u by 3 1 square. By solving, we will get 9 is equal 3u plus 5 minus u. Or by putting u is equal 2 meter per second in equation, a is equal 10 minus 2u by 3. And we will get a is equal 10 minus 2 into 2 by 3 meter per second square. And finally, we will get acceleration a is equal 6 by 3 meter per second square and is equal 2 meter per second square. Question number 13. A car travels with a uniform velocity of 25 meter per second for 5 seconds. The brakes are then applied and the car is uniformly retarded and come to rest in further 10 seconds. Find, first question, the distance which the car travels before the brakes are applied. Second question, retardation. And third question, find the distance travelled by the car after applying the brakes. And solution. Initial velocity u is given as 25 meter per second and final velocity v is given as 0 meter per second because brakes are applied, which means the object of the car comes to rest. Solution for the first question. Before the brakes are applied, let capital S be the distance travelled and we have the equation for distance is equal speed into time. And by substituting the value for speed and time, we will get distance is equal 25 into 5, which is S is equal 125 meter. Second part of the question. Acceleration is equal to final velocity minus initial velocity whole divided by time taken. That is, by substituting, we will get acceleration is equal to minus 2.5 meter per second square. Here the value of acceleration is negative, which means the object is retarding. So the retardation is equal to 2.5 meter per second square. Question number 14. A spacecraft flying in a straight course with a velocity of 75 km per second fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 km per second in the same direction. Then find, first question, the spacecraft's average acceleration while the motors were fired. Second part of the question, find the distance travelled by the spacecraft in the first 10 seconds after the rocket motors were started. The motors being in action for only 6 seconds. Solution. Given the initial velocity u is equal 75 km per second and final velocity v is equal to 120 km per second and time taken is equal 6 seconds. Now the solution for the first part, acceleration is equal to final velocity minus initial velocity divided by time. And by substituting the values, we will get acceleration is equal to 7.5 km per second. Second part, distance travelled by the aircraft in first 10 seconds. It must be the sum of distance travelled in the first 6 seconds and distance travelled in the next 4 seconds. And we can take it as S1 and S2. So S1 we have the equation ut plus half at square. By substituting we will get S1 is equal 585 km. And distance travelled in the next 4 seconds, take it as S2. That is speed into time, we will get 480 km. Thus, the distance travelled by the aircraft in the first 10 seconds is equal to S1 plus S2, which is equal 585 plus 480, which is equal to 1065 km. Now the solution for the third part of the question. After applying brakes, the time taken to come to stop, it was 10 seconds. Let S prime be the distance travelled after applying the brakes. Initial velocity given as u is equal 25 meter per second and final velocity v is equal 0. because it is going to stop. Using the third equation of motion, v square minus u square is equal to as. Substituting the values, we will get s prime is equal to 125 meter. Question number 15. A train starts from rest and accelerates uniformly at a rate of 2 meter per second square for 10 seconds. It then maintains a constant speed for 200 seconds. The brakes are then applied and the train is uniformly retarded and come to rest in 50 seconds. Find the maximum velocity reached. Second question, find the retardation in the last 50 seconds. Third question, find the total distance travelled. And the fourth question, find the average velocity of the train. Solution. For the first 10 seconds, initial velocity is taken u as 0. Acceleration a is equal to 2 meter per second square. Time taken t is equal to 10 seconds. Let v be the maximum velocity reached. So using the first equation of motion, v is equal to u plus at. By substituting all the value for u, a and t, we will get final velocity v is equal to 20 meter per second. Second part of the question. For the last 50 seconds, final velocity becomes 0 meter per second and initial velocity was 20 meter per second. And we have the equation for acceleration is equal final velocity minus initial velocity divided by time. Substituting the values, we will get retardation is equal 0.4 meter per second square. Total distance travelled is equal to distance travelled in the first 10 seconds plus distance travelled in 200 seconds plus distance travelled in last 50 seconds. So let us take it up S1, S2 and S3. So S1 equation ut plus half at square, we will get S1 is equal 100 meter. S2 is equal speed into time, we will get 4000 meter. S3 is equal ut plus half at square, we will get S3 is equal 500 meter. So that total distance is S1 plus S2 plus S3, we will get a 4600 meter. And the solution for the last question, average velocity. We have the equation average velocity is equal total distance travelled by total time taken. So that by substituting the values, finally we will get average velocity is equal 17.69 meter per second. Please don't forget to subscribe my channel Sajina.K.Jayasankar. And click on the bell icon to get the new notification. Thank you.